Okay, so I'm going to do some chapter 12 parenteral doses examples. These are two questions that are from your homework. I'm just going to do number 1 and 2 and show you kind of how to set those up and how I would kind of want you to get these problems set up every time that you're doing a question. I do this every time that I'm given a problem as far as math for nurses go or dosage calculations go. That way I can keep my information that I'm wanting to put in my sentence or in my problem, try to keep it straight over on the left-hand side of the paper. So, as you can see here, it says round to the nearest hundredth if the dose is less than 1 milliliter, and round to the nearest tenth if the dose is greater than 1 milliliter. So what that means, if you have a 0.182, this is obviously less than 1, so we would round this one up. This would be the 10th spot, this would be the 100th spot. So this one would be written as 0.18 because our 2 is obviously less than 5. If it was greater than 5, we would round this number up. If it is greater than 1, if we had 1.253, so any numbers greater than 1, we want to round to the 10th. So this one would be 1.3 because that is 5. So we are going to round this one up. So that would be rounded to 1.3. And that just gives you an idea of what I'm looking for as far as rounding goes. All right, so for the first question here, just kind of read through the whole problem. We have naloxone 0.2 milligrams IV every 30 minutes is ordered for a respiratory rate below 8 breaths per minute. So obviously this is important information. Is telling us how much that the doctor wants us to give or our desired dose. So I always write that over here to my side as desired, or D for doctor, as 0.2 milligrams IV every 30 minutes. Now this is saying that they want 0.2 milligrams given per dose, and we can, if needed, give this every 30 minutes. So that would be, this is one of the things that you're going to have to kind of learn to figure out as far as when an order is written to you in, if it says, give 200 milligrams IV every 8 hours, that's going to be a per dose medication. If you have something that says give 200 milligrams divided in every 12 hours, then you're going to divide that 200 by 2. So just kind of start looking for those bits of information. But this is per dose. So that is the first bit of information. The next, we have the medication is available in 0.4 milligrams per milliliter. So this is what we have on hand and the quantity of what we have on hand. So in this case, we're going to write 0.4 milligrams per, I write that as a over or divided by 1 milliliter. And then it wants to know how many milliliters would the nurse administer. So I always write over here, how many milliliters. So here's the information, and again, I always write this over to my left side so I'll know what information was in the problem that I just read. So when setting up dimensional analysis, I always start with my milliliters as my numerator. Anytime you're dealing with solving for whatever component, start with that number on top. So I'm going to put milliliters. So that's what I want to be in my first place when setting up my dimensional analysis problems. So now I go back over here to the information I have been given in this question. So I have 0.2 milligrams and then 0.4 milligrams per milliliter. Well, this one has milliliters in it, so I'm going to start with this, and I call these sentences because these are kind of taken out of a sentence up here in this word problem. And you can't pick and choose where your sentences go. So the information that goes with this cannot just be put into a problem just anywhere. So we would put here 1 milliliter is equivalent to 0.4 milligrams. So really we've just written this problem this way because we need to solve for milliliters. Now, to get our other information, to have these parts of our numerator and denominator to fit this whole dimensional analysis, if we have milligrams here, we have to continue on over here with milligrams. Okay, so we go back over to our other information. We've already used this, so we're not going to use that again. And then we're left with 0.2 milligrams is what the doctor, or what is desired that the doctor wants. And since that's per dose, I'm just going to put over 1, or you could put over 1 dose, just kind of whatever you feel comfortable doing, or you can just leave it, just blank. That's fine too. So from this point, what we do is we look at what information that we can cross out, because we want to end up with milliliters. So in this case, our milligrams here and our milligrams here will cancel out. So then we're left with 1 milliliter times, so that would be 1 times 0.2 over 0.4 times 1, or you just could put dose. So ultimately that would be 0.2 over 0.4, and that is going to leave us with 0.5 milliliters is what we're going to give this patient that the doctor has ordered 0.2 milligrams, and this is what is in the vial of the medication that we have is 0.2 milligrams, or excuse me, 0.4 milligrams per milliliter. Okay, and we're going to end up with that 0.5 milliliters. So let's start on the next one. This one again, so write all of your information over to the side of your paper. Again, if you do this with every problem, the more difficult problems that are going to come up, like micrograms per kilogram per minute, finding out for micrograms per minute, milligrams per dose, whatever the case may be, you'll be in the same kind of, you'll be doing it the same way every problem that you do. So here we have a patient has labetalol, 20 milligrams IV every 2 hours PRN for systolic blood pressure above 180 millimeters per mercury. So that would be our desired, or what the doctor has ordered, is 20 milligrams. And again, every 2 hours, so this is going to be 20 milligrams given per dose. The medication is available in 5 milligrams per 1 milliliter vial. So here we have our have, and quantity is 5 milligrams per 1 milliliter. And then how many milliliters will the nurse administer with each dose? So again, we're starting with milliliters, or we're solving for milliliters, excuse me. So that means we're going to start our dimensional analysis problem with milliliters on top. So now go back over to the information that you have written down, and we have the doctor wants us to give 20 milligrams per dose, and what we have in a bottle is 5 milligrams per milliliter. So I'm going to put my 1 milliliter here, and what goes with that one is 5 milligrams. So now we've used that. If this is milligrams, this has to be milligrams. Okay? And then we need to look back over here for our information, and so we're going to put our now desired dose as 20 milligrams over 1 dose, and then our milligrams will cancel out, and that's going to leave us with milliliters. So then we have 1 times 20 over 5 times 1. Whoops, that's not a dot. So let me change this, times 1. and that ultimately is going to be 20 divided by 5, and that will give us 4 milliliters, is how many milliliters we would administer for this patient to get a 20 milligram dose.